use variation parameters to solve the given system. So here's the steps you need to do when using variation of parameter method. First, you need to find homogeneous part, then find non-homogeneous part and add them together, which gives you final answer. Okay, so here's the step process. It's not step by step, but just a guideline. But I will walk you through specific problem. Don't worry about it. Okay, so back to the specific problem. Same as usual. First, you need to find the determinant of a minus lambda I. What is a minus lambda I? Let's call this matrix A, and then subtract it with base matrix times lambda. That gives you this matrix. So this is your a minus lambda I. Basically, you take this, subtract it with lambda I. Okay, so subtract lambda. That's it. Then take the determinant of it. It gives you this one. Set it equal to 0. So for lambda, you will get 1 plus and minus I, complex eigenvalues. Take a look at the case when lambda equals 1 plus I. Plug it into a minus lambda I. It gives you this matrix augmented with 0. You have this matrix. From the first equation, I know that ik1 is equal to 2k2. So for k2, I got 1/2 ik1. If I choose k1, 2, then k2 is I, and my vector k is 2i. Then my homogeneous solution is equal to c1 times vector x1, and vector x1 is equal to real part of vector k, which is 2, 0 times e to the t times cosine t. So why e to the t? This is actually e to the 1t. Where did I get the 1? This one comes from the real part of lambda, and cosine 1t. This one is coming from the real part of lambda, the imaginary part of lambda, okay? That is for cosine. Now minus imaginary part of vector k, 0, 1 times same thing, e to the t sine t. That is your first answer. Now for second answer, plus e2 times, so duplicate this one and make some changes. So for the first one, you have minus sign. For the second one, you need to have positive sign. E to the t cosine t and e to the t sine t stay the same. For the vectors, this one, you switch the position for your second answer, okay? And then if you work further, you multiply this in, subtract them together, simplify it, it will give you this matrix. Doing the same thing for this one, it will give you this matrix. This is a simplified form. Now for non-homogeneous part, similarly like a minus lambda I, you need to have vector, you need to have matrix phi of t, and this can be obtained from homogeneous part. Exclude c1 and c2, write down the rest in matrix into a matrix. So find the determinant of phi of t. It gives you 2e to the 2t. Okay. Then phi is inverse, which is equal to 1 over the determinant times this vector, but you need to make some changes. In the upward diagonal line, multiply by -1, so this becomes positive, this becomes negative. In the downward diagonal line, switch their position, so bring this up, bring this down, multiply them together, it gives you this matrix. Then you need to find u prime of t, which is equal to inverse phi of t times f of t. What is f of t? F of t is this matrix. Okay, so multiply them together, it gives you this one. Simplify it, you will get this one. So here's a little note from me. So when you multiply matrices together, do not switch their order. So it's not like when you multiply variables or numbers together. For example, a times b is not the same as b times a for matrix C only. Okay, keep in mind that, please. Now once you know vector u of t, you need to find u of t. So u of t is the integral of u prime of t. Okay, so take the integral of this one, it gives you this vector. Then your vector xp, which is non-homogeneous part, equals phi of t times u of t. Okay, multiply them together, it gives you this matrix. Again, multiply matrices together, do not switch their order. So seems like I can simplify this. Okay, so let's leave it as it is. And your final solution is equal to the combination of non-homogeneous part and homogeneous part, which is this which is this long answer down here. Okay, that's it.
If you find the video is helpful, feel free to give it a like, share, and subscribe to my channel in order to receive the most current videos. Don't forget to hit the bell so that you won't miss anything. I'll see you next time.